Elasticsearch. She's been working with us for how long? For
about 15 years.
Working in search for 15 years, and is very familiar with Elasticsearch. And she is here with us from the UK.
Just on holiday.
On holiday. So she's on vacation to come and give this presentation for us. So thank you, Laurie. Yes, Laurie's actually my cousin. And I will hand it over to her. Thank you so much for doing this.
No worries. Okay, so now you know who I am and what I've been up to. Quick question for you guys. How many of you are familiar with search? Okay, so we've got some people who know not much with search, because I was a bit worried that I was going to come into a dev thing and everybody's going to know, and I'm going to talk a bit about the background of it, and you're going to go, what the hell is she talking about this stuff for? But anyway, okay. So what I'm going to go over today is just a little bit of the background of search in terms of search engines and why we have them, why you would actually use a search engine over some other mechanisms for searching, like relational databases, things like that. A little bit of a description of what's in a search engine, functions it's trying to achieve. Some of the common problems we run into implementing search. So disclosure, I was a consultant in search for 11 years. So problems were my daily bread and butter. And there was a consistent theme across those. So I'm going to walk through some of those things to help give you some pointers if you're dealing with some search. Once you've got your search set up, how to scale it. And then Joseph's dilemma. I'm not sure who Joseph is. Is he in here today?
Oh, Joe.
Yes,
okay, all right.
Okay, so Joseph's question. I got an email saying, a little bit of a question. So I'm going to go over that at the end. And then if anybody else has got any questions, we can do that. All right. So Gerard Sultan. He was a professor at Cornell, but he's a PhD graduate from Harvard, and he generated something called Sultan's Magic Automatic Retriever of Text. Brilliant name. Marketing got their hands on it later and changed it to something boring. I don't know what, don't care. Smart is the one I like. So he was the one who created the very first search engine back in the 1960s. And this came about because of the works of a guy who came along a bit before him after World War II, and felt that there's a lot of information that scientists knew, but they needed some way to share it. And his whole idea at the end of all of his thinking was, we need to do this in a way that reflects the way the brain works. So search engines kind of have a little bit of a way of thinking like we do when we're trying to find information. Hopefully, that's the idea anyway. He also invented something called the vector space model, which is just a way of indexing bags of words, huge amounts of words, and finding similar content based on those words. He invented the idea of TF-IDF, which actually, there shouldn't be a slash in there, but TF-IDF is just a relevance ranking algorithm. There's a number of other algorithms that have come since. BM25, which is best match 25, which is based on that one initially. This one's kind of a best guess based on term frequency in a document. So for example, if you've got the word dog in a document and it appears many times in the document, maybe dog is an important word. But if dog appears very infrequently in the rest of your document corpus, then it's even more important. So that's basically, it's using the term frequency and the inverse document frequency. That's what it's based on. So then they came along with these other ways of, because you could end up spamming a search engine by just typing the same word multiple times in your document and say, boom, my document's important, when it's got no real content in there. So BM25 came along after that, which is more probabilistic and has a better results on document search, and most modern search engines now use that, but it's a derivative of that idea. And then he also wrote a book called Theory of Indexing back in 1975, and it's still the basis for what we do in search today. You can buy it on Amazon. So if you really want to know and understand how indexing works for search, that's the book. All right, so why would you use a search engine? Initially, search engines were produced as a result of government's documents having loads amount of unstructured text, and you didn't be able to find that content. So they are developed specifically to handle unstructured text. Relational databases are a lot more field value specific. I think more modern relational databases have a certain amount of unstructured text search, but it's nowhere near what search engines can do. Search engines on the other side also can do structured text search, because you just create metadata fields and you say, search on these fields, give me the documents that match these. And so you can do essentially the same thing, but the unstructured text is the big win. They're also a lot more scalable than other document access systems, because they have a way of structuring the data into segmented sort of compartments, chunks of the data that can be distributed as much as you want, really. So that's, yeah, and then also as a result of that structure of segmenting data, they also allow searching across the data in the same kind of segmented way. So the whole thing about them is they know they're going to be pulling results from lots of different places and aggregating it for a response. Another one of the features that they have in them is to improve document recall. You want to do normalization of your text. For example, if somebody is searching for a word that contains a umlaut E in it, they're not going to bother typing in the full structure. They're going to search in just AE, or maybe some variation of it. And that's where ASCII folding comes in. So it allows your documents and your queries to be converted on the fly, so that the normalized form of them is being used at search. It also reduces the complexity of your search engine, your indexes, because you don't have so many variations in it. Also do lowercase during search, because you really normally, case doesn't matter. There are some cases where case matters, but for the vast majority of searches, case is not a big deal. So just lowercase everything. Again, makes the words more similar, quicker indexing, quicker searching. The other thing is, end users don't actually have to understand the structure of the data, because the way search engines work is by default, if you don't know where your fields are and the way you're looking for things, you just search for the value, and it's going to search across everything. Might be a bit slow, but it does work. They do also support SQL-like queries for those that like SQL these days. I'm not sure that that's an advantage, but they do these days. Does anybody have any questions about the differences between search engines and relational databases and why they're different use cases? Okay. So the things that a search engine actually does. So I tried to organize this by the left-hand column is things that people might think about in terms of what they're trying to do, and then the stuff on the right is a little bit of an explanation, and then the term that's involved within the search world. So organizing your documents, basically indexing your documents. That is the term we use, which I think even in database language they still use that word. Being able to find the documents quickly, searching for the documents. You want to be able to filter them. Security is quite often an issue, especially in government industries, legal industries, so on. They have these, document ACLs. All of that stuff can be added into your search, your indexes, so that it can filter searches, filter results at search time. Users also want to be able to dive into things a little bit more. Think about using Amazon. If you use Amazon and buy stuff, they've got refiners on the side that say, oh, I want to buy only interested in these sellers, or I want Prime, not 3 days service, I want tomorrow. Those are your ability to allow users to select, you'll use facets, aggregators, navigators, depends on the search engine you're using, those are all the terms they use, but basically that's allowing you to dive into things using a refiner. The results need to come back in a certain order. Sometimes if you're doing something like looking for a new job, I don't know if anybody's looking for a new job, but if you're doing something like that, you might care about the distance to travel. That would be something that would be used in ordering. Relevance ranking is a different one. This is where these things like TF-IDF, BM25, and other custom ranking algorithms can come into being. And that just allows you to present the documents in a way that makes sense for your user base. Sometimes you can even change that based on the type of query being used, or the data. You can change it based on the data. You can also change it based on the queries. Suggestions. If you want to be able to provide type ahead or autocomplete, those are built into search engines these days. It'll come off of your indexes. There are features attached to them that allow you to just do that out of the box. Spelling. Most of them also provide a did you mean style feature, because people fat finger things, miss letters, they do things. So search engines provide that kind of thing as well. And then you can start getting into more complicated behavior, linguistics. You can expand the search. So if somebody's typed in spoke, you also want to find things where somebody's speaking about something. Those would be your lemmas. So they're the contextual dictionary terms related based on context. Stemming is a little bit more aggressive and simplistic version of it. There's different methods for reducing words to their stemmed form, ranging most of them from quarter stemming is the most aggressive kind, which really cuts words up a lot. Like if you're looking for the word animal, you might find things that are animation, because the stem is the same, anim, which is not very useful. This example came up at Lego. Somebody's looking for an animation and they didn't really care about animals. So stemming can be done in various forms, but lemmas is a better form of the same kind of thing. It just requires a bit more work. Synonyms, words that mean the same. Somebody searches on this particular word, they might also need things that come from different forms. Usually that comes into being when you've got, say, product descriptions or things like that, where you say, I'm searching for this particular item, but it might also be termed, have another set of terms that match that same value. You can add dictionaries to your search engine to use synonyms. Stop words is another thing that people say, you know, there's a lot of back and forth. Do we include stop words? Do we exclude stop words? People think that, at least back in the day, stop words were something we excluded during indexing because they consume space in the indexes and they're essentially fluff, and you could just ignore them. These days, people say, well, we've got so much in the way of resources, don't really care. You can get the full phrases a bit better. And for one, who knows whether IN means Indiana or in? Better not to exclude it. Okay, so any questions about any of these things here? Really speaking a bit fast because I'm a little bit.
So stop words is like the things that in the general course of events are not very useful. Okay.
Are these things generally built into search engines, or do you, like, let's say, for example, knowing that a word is similar to another word, are those things built in, or do you have to kind of train it to say?
You have to tell it. So if you have synonyms, for example, you would have a synonym dictionary that has meaning within the context of your organization, and that would be added to or configured into the search engine. So search engine knows how to use synonyms. You just have to provide them.
So like a default list, and you can like say, I want the general ones, and then we'll have the specific ones for our project.
There's not a lot of default synonym dictionaries because synonyms are quite heavy duty. For one thing, you can either add synonyms at indexing time, which bloats your indexes, or you can handle them at query time, which of course bloats your queries. So you just have to balance where the resources are that you have. So how you use them, because if you think about it, all you're doing is saying, add these values to this one to say this thing also equals these things. It's got to be indexed or added to a query. That's really what it's doing. So synonyms, I think there's better ways to do synonyms. You can do things by actually just normalizing terms. So if you create a list of words that have value or keywords for the document, instead of putting synonyms in, adding to the document, you can say, these are the words that have value, but you have now converted them to keywords. So you're saying these are the values that have value, These are the terms that have value for me on this document. And that same conversion could happen at query time, so that whatever they type in, they're only looking for a small subset. So you're not bloating your indexes, and you've got a service that says, take this and say, what does this really mean in terms of our data corpus? Yeah, so rather than creating big queries or big indexes, do a little bit of processing to get a better result. Okay, so implementing search. These are the big common problems. Now, there's one problem I didn't list there, which is probably problem number one, and that's they never listen to you. But
you mean they never listen to the consultant?
Yes, so you're always saying the same thing over and over. Worst case.
My experience, they never listen to people here. You have to get the consultant to say the thing you're saying.
Well, then they might fix it, and then 2 weeks down the road, they've gone, oh no, I've got a better idea. I'm going to do it this other way, and then they'll call the consultant back and say, why is this not working? Because you undid what I told you to do. It usually happens on about an annual basis, the undoing what you told them to do. That's okay, pays the bills. But it is a bit frustrating. So, okay. So the real first problem is more often than not, people don't actually know what data they have. They've got a huge amount of data all over the place, different forms, and somebody from upper management has come along and said, give me insight. Now what? What do I do with this? So the first thing you can do, given the power of search engines, is actually just shove it at the search engine. Don't really worry too much about structure. Don't think about what you do or don't have. Just push it at the search engine, and then you can start exploring it, because they have lots of tools for just exploring the data. It may not get the right types, it might flatten things, but it gives you just a way to start exploring the data within a search engine using one of their nice little applications. In the case of Elasticsearch, you've got Kibana. Gives you ways to just start poking around in your data just to see what you've got, and then you can come up with an idea of what you have and what you might want to do with it to provide insight. After that, underestimating data processing. Garbage in, garbage out. If you don't process it, you won't get quality search results. So when I said just throw it in the search engine, you'll get something, yeah. That's one of the cool things about modern search engines is, you know, you throw it all in there. Yay, I got search. Should be. It's not quite like that, because you lose context, you lose relationships between things. So you do need to understand the data first, and then you need to build in those relationships and think about how do you structure the data in order to make a good search experience. So this is where data processing comes in. And from my experience, I'd say that's 80–90% of the work. Is getting the structure of the data right for your search engine, defining what the data needs to look like in your search engine and how you're going to get it there. That's a lot of work usually.
Let's say you have a large amount of data. Is there any way you can do like some machine learning or something like that on the data? So I just had this debate where we're talking about like center archivist type stuff.
Mm-hmm.
And we had the archivist saying like, it has to be like manually touched by a human being with all this wisdom. I'm like, how are you going to do it? It's one person and the whole center generating like a bunch of data. Like that doesn't make sense, right? To me, it's like nowadays. So we went back and forth. Needless to say, I probably didn't win that argument. But,
yeah, I
so
think the archivist usually knows what they're talking about.
Yeah, I get it.
Professionally.
But another subject altogether. But so let's say, for example, like you have this large amount of data, but you want to clean it up. It's the same statement you made is the same statement you made to me, like garbage in, garbage out. So like, if I don't have anything in, then I'm going to get nothing out as well, right?
Yeah, well, that's why just shove it in there, as much as you can of it representative-wise. You don't have to do all of it. Just find as much as you can, as fairly representative as you can, and just shove it in there just to start poking around and see what you've got. You might decide you need to get your data scientists involved with some machine learning to try to do a little bit more, actually even Elasticsearch has a machine learning piece to it, but that's more for learning about anomalies in your logs, for example. It doesn't really do machine learning just randomly on data. You would, if you wanted to know more about, trying to think.
Well, there's things like topic, like
yes,
you know, you
so
do
you're
machine
trying to
learning
figure out what
about
categories and things
topics,
like that. Exactly.
clustering.
So you can say, oh, wait a minute, I've got lots of documents in this. Thank you, Christian. I got lots of documents. I would have got there eventually.
Sorry. I only say that because we have
remember, but that's exactly it.
Who did that actually. Over the
So
summer.
in order to organize your data in a better way, you can use some machine learning to help you get there. And maybe that's what you do before you even just toss it in there. Get somebody to try and compartmentalize and say, I've got categories of data that look like this. Now we're going to throw those into individual search engines and dive into them a little bit more to see what fields do we have, what values do we have, what kinds of things are in there, and that you can use a search engine to just get a bit more detail. But if you want to just categorize your data, machine learning is brilliant for that.
Can I say this is like a tie? I want to say we can, there's like, you don't have to do, it's not either one. It's not a zero-sum game. Like you can put the data in there and then still kind of massage it afterwards.
Yeah, that actually comes to a couple of the other topics.
Okay, shut up, Andre.
But it's a common problem, especially with upper management. So I will get there. All right, so data processing is a big deal. You have to spend time on it. Otherwise, your search is really probably not going to serve its purpose. There we go to thinking a search engine is magic. That kind of ties into all of these top three kind of all together. Throw your data in, I got search results, happy days, and then 6 months down the road, why are my results returning poorly? Why are some of my documents not indexing? The reason they wouldn't be indexing is because if you just throw it in there without defining what your data is supposed to look like, the useful feature of a dynamic schema can happen, but it looks, the first time it sees a field and goes, oh, this looks like a integer. I'm going to make it an integer, adds a value. 2 weeks down the road, you have a new document with the same field name. This time it's a string. Elasticsearch, Solar, or any of these other ones to say, badly structured data and toss it right back at you. So if you know your data, if you had a chance to play around it and poke and look at the field values, you can go, ooh, look at that. Some of these are sometimes strings, sometimes they're dates, sometimes they're integers. Maybe I should do some data processing and normalize that field before it gets to the search engine to have a real chance of searching on it. So if the fact that it's sometimes a string and somebody's just quoted your time in milliseconds, and sometimes it's an integer because it's time in milliseconds, and sometimes it's actually the date, you want to be able to search on that in a uniform form. So normalizing how it appears in your search engine allows you to actually search in it in a way that makes sense. You might just make it all milliseconds or something and figure it out later. But that's a really good example of where data processing, in order to normalize the data, helps your search. So search engine looks like magic, but it's not. Then we get to incorrectly using the query language. People using your API or generating an API against a search engine. Upper management comes along and says, hey, I need this feature. And they come to your search engine and they go, oh, look, I've got these fields and that, and I can do this. And the documentation says I can build these big aggregations, and I'm just going to all these things together, and boom, I've got a result for upper management. But in order to do that, they're running massive, really unwieldy queries because the data isn't structured in the way they actually need it for this feature, or they are running lots of queries and hitting your query frequency rate really high, which is going to block other searches on your indexes. Yeah, so using that query language incorrectly. Devs that are saying, kind of gung-ho and jumping in there and say, yes, I can do this, and they're doing a brilliant job, good for them. That's great, but you actually need to talk to the people who've created the indexes to make sure that the features are there to support what you're doing, because badly using a search engine can lead to really bad latencies for everybody, not just the person creating bad queries. One-time configuration. I have stood up my search engine. I'm done. I'm gonna walk away and leave it now. It's going to run forever. Not quite. Resources run out because you keep adding more data. Hardware fails. Got to do it again. I had some cheat sheets suggest things on this one. Ding. Okay. Yeah. Course requirements can change. That comes back to somebody using the data incorrectly. So if your configuration works for a given set of requirements and some unknown requirement comes along that needs something else, you may be able to just add it in. It might just work, but the chances are you're going to need to either increase your resources because you're adding more documents to support that feature, or you've suddenly got a lot more queries coming in to support that feature, so you need to increase the number of replicas you've got, any number of things. So your configuration could change as a result of requirements that come in, or just over time because you've got more documents in the system. Expecting your result quality to stay the same. So if you're using any form of relevance to score results and order your results, the document results documents coming into the system itself will change the order of your results because they affect each other. It's part of what they do. The relevancy is the relationships between terms within the document and between the documents. So expecting your result quality to stay the same as documents come into your system is not going to happen. Another thing that can happen is, relevance tuning. Again, if you're actually using relevance at all, your requirements change. And so what is relevant yesterday or week before or 3 weeks before may not be relevant today. So you're constantly having to look at changing the way you return results to users. Costs, restricting available resources. It's another big one. You've got the requirements from management, and then they tell you, I've got these resources available to provide hardware to you. And sometimes this is a bit pie in the sky when the resources are just not going to allow for it. So actually coming back and saying, look, if I put this and this and this feature in, these are the requirements for the resources that are needed. So either you give me more resources or we cut back the requirements, because quite often if you try to meet requirements with limited cost, you're going to end up with really poor performance. And that just impacts your users. So if you're an internal house, frustrated internally, people go, oh, crappy system. But when it's your customers, that's a big deal. All right. Aggregations, ignoring the performance implications of them. Aggregations seem like a really cool thing.
What are aggregations?
Oh, sorry, that goes back to slide earlier, but aggregations, navigators, facets, they're all the same thing, but basically they're a counter, or there's other forms of them as well, but fundamentally what they're doing is going through all the documents and saying, for this given thing, how many do I have? So they have really big performance implications because they actually have to go through all the documents to add it up. And the more terms that you're trying to add, so if you're saying, oh, I'm just interested in the top 5 terms for this field, how many documents do I have? That's not as bad as saying, no, I want all of the terms I have for this document, this field, because it's got to go through every single item and every single document every time to give you the number. If you've got fairly static indexes, you could create separate indexes that specifically are designed to just generate the aggregation results, or you could have more, again, less static, even with less static indexes. So if you're constantly updating your indexes, those aggregations are not even going to benefit from caching, because every time they have to go back and get them again. So aggregations are something you use with caution, because they will impact your performance, or you have dedicated servers designed to handle the aggregation specifically.
So when you're talking about like size of engines, like when you're talking about these things, like how many documents, like how big is this?
Okay,
Like have you worked on
so
it?
I've done things that range in size from, I don't know, a couple million documents to 150 odd billion documents. And to be fair, I will say that I've managed to run in Elasticsearch 154 billion documents, which range in size from, they've got quite a big range in size. So the actual corpus of documents indexed was almost a terabyte. Actually, I think it's 1.2 terabytes now that I remember. Single node, 20 shards, which probably doesn't mean a lot to anything. So sharding, I should use the word here, is a segment of the indexes. It sort of breaks the index into pieces so that you can have searches running across individual groups of them in parallel. Okay, so I had 20 shards, 154 billion million, no, it was million, not billion, 154 million and 1.2 terabytes. So, and that server actually managed to produce reasonable aggregations in a big dashboard that one of our data scientists were using on one node. The reason I had one node was because he actually did this on the live environment for the same set of aggregations for his dashboard. And we had the gateways timing out. You've seen this problem.
Yes.
Gateways timing out because although Elasticsearch was being able to run the queries, it was taking its time, eventually getting back, and the 30-second timeout on the load balancer happened. So he never got his response in the browser. He kept hitting refresh, waiting for it, thinking he had a problem in his browser. What that did was kept sending requests to Elasticsearch, and it kept trying to generate the same results. And it blocked all the searchers. And all of a sudden, monitoring guys came and said, "What's going on with Elasticsearch? No responses are happening. What's going on?" And I was like, well, looks like we've got some big running queries going on. So I started digging into it, and I discovered it was this one guy. I said, all right, data scientists, stay away from production systems because you can't analyze stuff people are just using at high volume. We created this one instance, which was slow, and he had a browser inside the load balancer. So we weren't trying to set a load balancer timeout of 3 minutes or however long it took, because ops didn't want to do that. So we had a server dedicated for the big searches, a bit slow, but it did the job. Okay. So you have to figure out what is your end goal, how many people, how big the data, in order to define your structure. But, you know, if you've got one guy using the thing, you really only need one server, beefy one, if you've got a lot of data, but you can get there. Okay. Any other questions about these issues? Are there any? Well, no, we'll get to it later. All right. So this is where we get to scaling your implementation. So scaling just means taking it from one guy using it to hundreds of people using it at volume. It also means your documents have grown from 20 million to 150 million or whatever, and will continue to grow. So how do you do that? One thing is, as your data volume grows, you scale horizontally. That means adding more shards. You're just going to essentially add more shards. You might add more nodes with space for shards.
What's a node? A node is just
being
a
computer.
Gotcha.
Or JVM. Don't use JVM. Okay. But you can, basically just another piece of resources that's got hardware behind it, data volumes, networking, blah, blah, blah. The more you have, more data you have, the more of those you're going to need, just going out horizontally. If your query rate is increasing, the more users you've got, you need to scale vertically, add more replicas. So basically just copy each row of data again, because you would send queries out across all of those replicas. And the more queries you've got, I think there's actually a limitation in terms of the number of threads that are available. You're going to have, for every shard, you have a query thread being being used, and you're going to be limited by what's available in terms of the resources on your hardware as well. So scaling vertically gives you query performance. And then the big one, balancing your number of shards versus the size of those shards. So sort of the holy grail from Elasticsearch perspective is one shard, one node. But they also say no more than 50 gigabytes in one shard. And that's because search performance starts to drop off at 50 gigabytes. And actually, I found when I was dealing with those bigger documents, the bigger the documents, it's not really size at that point. It's actually probably more like numbers of documents, and you've got big documents because it's loading things in memory off your shard. So the number of more shards you have, the more searches you have. So the more aggregation at search time has to happen on those results. So if somebody sends out a big query and you happen to have 20 documents and 20 shards, you're going to have 20 searches to come back and give you a result for essentially 20 documents. That's actually a lot slower than it needs to be. You could have just put all those documents in one shard. So more shards isn't always a big thing. Also, bigger shards isn't a good thing, but you can grow them up to, I would say, limit them at about 45 gigabytes. You can go up to 50 according to Elasticsearch, but things get really slow at that point if you're using this in a production environment. So how do you do that? When you want to decide how many shards you're going to create and how big they're going to be, you start with one. You get a representative piece of your data across your data set, because you don't want to just take 5 documents from one index. If you've got 3 indexes, or you've got, actually even better if you can limit it to one index and size your search engine based on one index, that's even better. But
why would you have multiple indexes? What's an index?
An index is the equivalent of probably a database. Actually, it's probably more like a table in a search engine, in a relational database. It's a collection of documents that are related, so they have the same schema, and you would search on them in the same way.
Gotcha.
So yes. So how would you balance do your shard scaling? You would take a representative set of documents, kind of try to guess how many of them are going to fit into a shard at capacity, which means you want to try to guess. So if you've got, if you've been doing indexing at all with your stuff, you've probably got an idea of the compression rates. If you say, if I'm sending in 20 gigabytes of data and I end up with 10 gig index, then I know what my compression is. That means I've now got to find it for up to 45 gigabytes of data.
It'd be like 90 gigs coming in.
Yeah, exactly. 90 gigs coming in, and you want to go across your data set and find 90 gigs worth of data that represents your data set as well as possible. Index that into a single node, single shard, and then you can start playing with things like the hardware resources around that to see if I'm running queries, to use test tools and other things to run queries at high volume, see if I've got low number of queries on this type of network or CPU, all of these things, trying to find what's the best piece of hardware for that node at that size. And then you just literally do the math after that. Once you figure that out, you can say, all right, now I know what my current data set is. I know what my projected growth is. You probably want to plan your scaling of your cluster to support up to a year's worth of growth, because ideas always change within a year, and so do budgets. So plan, because you also can't change the number of shards all the time. Re-indexing all the time is the point. So I'd say project your cluster size to about a year, and then you just create your shards up front and you just index into it. Usually that works. So you can plan ahead. You just have to say, what can I get into one node on one shard on one node, and then scale it from there. It is pure mathematics at that point, as long as your data doesn't change. If you start trying to create a new type of index on your cluster or totally new type of data, you actually need to go through that sizing exercise again to make sure you're not going to go out. Because if you set up your infrastructure and you say this is now supposed to scale and last for a year, and in 6 months falls over because you run out of space or your memory's, not sufficient, and then management is going to go, why have I got to pay more money for this thing? You said it was going to last me a year. So you have to be really clear that a scaled and defined scaled size of a search engine, it has to be about a known data set. You can't change the requirements and expect it to stay the same. It won't. Last but not least, your JVM. Lucene is the underlying indexer for Elasticsearch and Solr, and it actually uses the file system cache and is very and actually needs quite a lot of memory. It's quite memory hungry. So for example, if you've got 60 gigabytes on your machine, you allocate a third of that to Elasticsearch, the rest of it's going to be used by Lucene very happily. So it's not wasted.
You said no JVM in production. How does that work?
No. Did I say JVMs? I meant virtual machines.
Oh, sorry. Okay, that makes more sense.
Virtual machines before. So yeah, you've seen at this point, we're doing for time. I think we're way ahead. I've been talking too fast. No, I came late. What other things about Lucene? Yeah. The other thing with the JVM and Lucene is you should make sure that there's no swapping enabled on your hard drive, on your machine. And if you're unable to disable swapping, you should configure two things. One, the minimum and maximum heap size for Elasticsearch should be configured the same. And the second thing is the bootstrap memory lock should be set to true. So if you have swap enabled and you can't disable it, you need to do that. I think there's some nifty, there's some information actually in the heap settings information on the Elasticsearch documentation that includes that information. But that does help. All right. Do we have any questions about this piece? Joseph Stalem. So, this is the information I got about the infrastructure and what we've got. We had one node, so one machine, I assume. It's not, is it a Docker container or is it an actual machine with other stuff on? Okay, well, it's a production environment.
Well, basically, yeah. We just talked about that.
Okay, all right, so it's basically production. So then I saw 212 indexes and 226 shards. So I was like, okay, so some of those have multiple shards, but most of them are going to be single shard indexes, which is good for the index itself. 26.5 million documents, and then I almost fell over when I saw 5 gigabyte JVM heap for that size document set. How is it even working?
It's actually working very well.
This is one of the good things about Elasticsearch. It always surprises me. I suspect that means you don't have a high rate of requests hitting it.
No.
Yeah.
Right.
So you've got a very small set of memory there to handle quite a lot of indexes.
This system is an internal system, right?
Yeah.
So, and you're running it like a few times a day, maybe.
Right.
So one person, a few times a day.
Although we have had people that can build a lot of very greedy aggregation charts and show them the one dashboard.
So when you,
and then you get those bad gateway timeouts, which is
yes. Okay. Yeah. So we'll get to that. The daily indexes for ingest and distribution. The way I understood that was you've really only got 3 types of for that, and then the analysis records. You've got 3 types of indexes you're creating. So 7 of those indexes are going to come from your analysis daily rollover.
Yeah.
And the rest of them are split between ingestion and distribution going back for however long. So basically daily indexes. All right. So that's a lot of indexes. So the question I had a couple of questions here. We had
So for just a little bit of context, this is for us to, we're an archive. This is for us to understand what data we are bringing into our archive and the sort of statistics around that, and what data is going out of its distribution, going out of the archive to people. So we monitor these things to make sure that we're getting everything we expect to get, and that when we do the distribution, people are getting what they're asking for. Is that right, Joe? Is that right? Okay.
Is that a native search thing, or is that like a data volume and just consistency? Is a search engine the right tool for that particular?
We're not approaching this from a search engine perspective. We're really relying heavily on the rebuilt visualization capability, especially to like drill back in time to create just on the fly visualizations and queries.
Something that's what I'm thinking. Like it didn't sound like a native search thing. It sounds like a.
But the search
like maybe the tool. I mean, you're using the visualization side of the search, but the underlying engine may not be the right engine to provide that visualization.
Well, most visualizations are going to have, even your Power BI and all those things, they're going to have search engines somewhere behind them.
Yeah.
They don't know what to do with data themselves by nature. So your search engine is still going to be the mechanism that is used to generate the results that go into your charts.
Some of this actually is in a database with a scan, right? At the instance, there.
Also, I don't know if you mind if I. Okay, right. So the way the full system actually works is we have a bunch of the archive machines and essentially custom code that we wrote on those. They feed in to a centralized Postgres database, which has been our historic record going back for 15 years, maybe longer. And so what we actually, when we started experimenting with this, we have the Postgres database export a bunch of that information. We do some Python post-processing, and then we ingest directly into the Elasticsearch node. And then we played around with the dynamic index templating to make sure that everything is going in ideally the most performant way that we could. Part of the reason why we broke things up so particularly on a daily basis is because you can often get, we often want to look at this as a time series. So I thought that the best way to do that was just by day. But it sounds like it might be better to chunk it all together.
You can actually create your index. Each index, it depends on how big your indexes are individually on a daily basis.
They're very small, actually.
So that might mean that because you can, if you put a timestamp field in your document, the daily timestamp field, your charts will still use that field. You can tell it which one to use and create much bigger indexes. So if your indexes, that was the other thing I was going to say, how big are those documents and how big is the index on disk? Do you know?
So in total, it's about 98 gigabytes, which from what you're saying isn't actually that large.
You could have two shards with that, essentially. Okay. So, well, actually, since you've actually got 3 indexes there, so that's 7 rolling days, million records. I don't know how big a percentage of your total data set is that? That's more?
That's
more than half.
Yeah.
More than half.
Yeah, so
that would probably need 2 shards.
Okay.
Because, and you could create it in a single index.
Okay.
So if you did that one with 2 shards, because if you said that's about half of your data set and you've got 98, yeah, so that would have it nice and comfortably around 24, 25 gigabytes per shard, and you have some room for some growth there, and you can keep all 7 days in one index. But just make sure you have a timestamp field in there. That will help both indexing and search.
Where are you indexing? Text is lyric, is it?
It's so primarily, well, it's text, numbers, sometimes I can use visualization.
Most of the field are text, but the things that we aggregate are numeric. So basically, we're using this for all our metrics, index metrics, distribution metrics. So eventually, we're gonna look at that as the plot of those values, some unique count, all those things.
There's a lot of time slicing too. So there's like the duration of individual granules and the ingest time. Yeah.
So I'm saying it's like a time series database. Like mean, I get the graphical part of it. Like we had the same thing with like you have your normal database. Most times that's like a relational database underneath the covers, right? Then we had like relational data, which didn't really, it was very painful doing a relational database, probably me. So we ended up adding a graph database on the side where the data was kind of just graph data over there. When we need to do relationship things, we did it in the graph. And when we need to do like the storing data, we put it in the SQL server. And then when we needed other things, we put it in Redis. So those like the right data store for the individual problems. But on the front end, the cover, I mean, what people see, they don't know what's happening, but we're using the most efficient data store for the, we're duplicating the data in multiple places for the data that for the operation that we needed.
So Elasticsearch was actually built with analyzers, with the idea of dashboards on logs specifically.
Yeah.
It's designed to deal with this probably better than anything else that I know about, because that's what it was doing from day one, and it's only improved. Other search engines aren't always as good at that, but you have a very valid point. A search engine is not a data store. It is a search engine. It's a way to get the value out of your data without necessarily storing that data. So if you've got big blobs of data associated with the things that you're searching on, they should be somewhere else. You just have a link back to it in your index so that you can find it again. So it comes back in your result and says, this is the value that lets me find it somewhere else. So it looks like you should be able to create a smaller index. That should help your query time, because it's not going to be going over. It's only 7. It's probably only got 7 indexes for those 7 days, I would imagine. So actually, do you have a lot of issues on that particular one?
No, it's not actually that.
I was going to say it's the other ones.
It's a very long time series on the distribution metrics.
Yes, so if you've got a day index that's tiny for every single, that's kind of like my 20 documents with 20 shards. Don't do it. So yeah, you could combine those. So you could figure out what a good number is. If you look at because you've got it going back a while, you could look at the individual index sizes going back and say, how many of these index makes up maybe 25 gig, because you want to have a little bit of room for growth, because you're going to have to rescale again in a while. You can also see how fast it's growing. So your scaling exercise should be pretty easy. You've got the numbers already. You just have to look at it and see, how do I scale this? How big do my shards need to, how many shards do I need for this index, and just make it one index.
Recommend for retirement in terms of the life cycle of the indices? Because in this framework, we're planning on rolling everything off after so long, because we don't need to keep them.
Yes.
We're fine with like
if you have a rolling 7 days, I would. So actually, because that is rolling 7 days, you could leave that as the 7 days individual indexes.
Okay.
It's not a big deal. It's only 7 indexes, and you can roll them off. For the other ones, I would say, what is your point at which you want them to start disappearing?
Just chunk it.
Yeah.
Okay.
Actually, now that I'm thinking about it, if you're trying to do a rolling 7 days, it's a single index. No, you want the individual indexes. So the other ones, you could chunk it, say, all right, we'll keep a weekly or a monthly chunk rather, because that will consolidate significantly the number of shards that you have involved, or indexes you have involved. So just reduce it a bit. And then you can just delete as you want, one month at a time at the back end of it.
One of our distribution indexes is already that way, because we keep the daily index for maybe 30 days, but more historical one, we keep it as monthly.
So you have
everything into 1 month.
You have been merging them already, and then you search over those as well.
Yes.
Yeah.
So essentially, of those, but you're still searching potentially over of the ingest and distribution. How many of those 212 indexes do you think are?
Well,
Maybe half
Half and half?
The index metrics only keep for 30 days. Only keep 30-day index, so it's maybe 30, 40 indexes. Most of them are distribution, those daily and monthly combined.
Okay, but either way, you're potentially searching over 100, nearly 100 indexes at any given time. So that is a potential issue. The other thing you could do, say, look, I need to have 100 indexes for whatever reason. And But that would mean that you need to increase the probably need to increase the resources available on the instance. So you've given it 5 gigabytes for your JVM. That is being shared across all of those indexes, which means each index is getting this much memory, nothing. So it's not being able to take advantage of caching or any of those other things. So your aggregations are going to struggle. The other thing you could do is just split this up into multiple nodes, allow resource allocation. Now that's going to come into cost again, because now you're saying, I want more boxes.
We just had a discussion about speccing out a system to dedicate to just this. This is very helpful.
This is very, and this keeping track of this is one of the core things we have to do. So
you could split
getting
this.
resources is not necessarily totally impossible.
So if I was saying, if you had Happy Days, unlimited budget, you don't have a huge document set here.
Well, sorry to interrupt. We do. I want to add a lot of system metrics to this as well. So start ingesting these module streams to kind of co-locate uptime and maybe application performance monitoring. So I would expect
that would be
grow.
another type of indexes then.
Sure.
So they could have a dedicated cluster for that based on the data type there. But based on what you've got right here, 26.5 million records. Depending on how you manage to reduce your things, I would say you could have an instance that has 20. If you had 20 gigabytes allocated to the JVM, you would get much better performance. I don't know what you've got on your machine. Do you know?
Wow, you might be able to.
Well, don't forget Lucene is going to use another half of that. So Elasticsearch recommends 50% at most allocated to your Elasticsearch. My testing with my data showed that actually a third was a better number, but that was because I had a lot of very big documents. So you may be able to play around with that a little bit to see where your performance changes. But start with about 30%. You can shift it up a bit. If your JVM is hitting 75% usage on your Elasticsearch, you need more replicas at that point, because that's usually queries. But you don't have a lot of users, so I don't think you're going to need more replicas. I think what you need to do is figure out your shard allocation, add more memory, and preferably split them up a little bit. Another thing I found is if you have big drives associated with your volume, your machine. Don't know if are they network drives, SSD. So your network drives, that's going to be a bit of a hit because I/O is a big thing as well. So if there's a way to improve the more memory you have, the less it has to use on disk. So that's where Lucene's going to be used in a lot of the memory, trying to allocate, get things out of disk. But you're running the same types of searches every day. You probably should be able to make use a lot of caching. So memory is going to be your friend in this case. So if you can give it more memory, just don't go over the magic 20, I think it's 26 gigabytes is the recommended max. 32 is the absolute max unless you've got a huge amount of memory because of the Java pointers in the background.
Okay.
You can't allocate the thread. It starts doing some weird ass stuff with the memory there. So 32 is the absolute max, but you need to leave some room for the JVM itself. So 26 is a good number at most. I used to allocate 20 and leave the rest to Lucene to figure out on a 60 gigabyte box. But I think if you did that, you'd get massive performance improvements. However, if you are still having problems with your dashboards and generating these aggregations, if they really are big, it might be worth considering taking a closer look at what you actually got in your aggregations. Are they terms? These, so you want to look at things like the field caching and the document. What's the other one? There's some new stuff that Elasticsearch is recently done. And what version of Elasticsearch are you using?
7.
Okay, so you're pretty recent. So yeah, there's different methods of caching that Elasticsearch uses. So you can take a closer look at what they do for their aggregations and how to speed up performance there. The other thing is just making multiple dashboards. Don't make one query doing 20 aggregation requests at once. Break it up a bit.
Thank
So I think that's it. Any other questions?
So would it make sense, just if you're setting up multiple shards, would it make sense to do it more by usage pattern than more tying it to actual data sets? Like,
Usage
Yeah.
pattern is everything when it comes
so
to
like
defining your
one
search
for
engine.
dailies, because it's a lot of queries for smaller data sets. Then you have less queries, but for bigger data set like weeklies, and then even less frequent, but even bigger data set like monthly or something.
Yeah.
Would it make sense to set it up that way?
So that would be, I think, more about your index creation. So there's a difference between indexes and shards. An index is a collection of data, and an index may consist of multiple shards. A shard is by itself really another index. It's just that Elasticsearch knows how to work with them as a group of indexes, treats it as a single index, but it's just for memory management and searchers and indexers to be able to handle them. So if you're trying to define how your user base works with things, that's how you define what your index looks like. So if you are creating an index, as you say, per day for 7 days, because you've got a high volume of requests across, is it?
Something like a news site, something that gets a lot of usage for the recent stuff.
Exactly.
But every now and then someone still needs to find old stuff, but just not as frequently.
Exactly. So what you could do then is set things up so that your high volume, high traffic stuff has the high spec machines with more memory and all the rest of it, and shift older indexes onto other instances, and then run queries that allow them to pull from both sets of indexes. So don't make Elasticsearch do the aggregation, you do the aggregation at that point. So you're saying, well, there's ways to do that that can work with your resource allocation versus your user needs. So if you've got if you need to have high spec performance on more recent stuff, then you set up just your recent indexes, and then you shift things into older stuff. But now that's going to make a change in the way your user experience works, because now they're going to look at it and go, I'm just searching away, I'm getting everything that's recent, but now I want something from last week. This is a different type of search, so it can be part of the user experience to allow you to make use of the resources you've got and the structure you're making.
If a user has like normal dashboard and they don't know that we have different indexes behind the scenes, if they they're viewing everything by default, let's say on daily,
Yeah.
and then they just make it a little wider and suddenly they're going over 4 days, and now behind the scenes we want to use obviously a different index. Is there a way to make it?
So if you're
transparent?
using the default dashboards in Kibana, you kind of stuck with having it all part of your same index cluster. You can't really change that. If you want to build custom user interfaces, then the world is your oyster, really. You can build anything you want to make it work with your user requirements at that point.
So it's 1:20, and I think people have to
I'll
probably
go back to
go
work.
back. Yes,
I
I
think people have to go back to work.
Yeah.
Thank you so much. Yeah, no worries.
But thank you so much for doing this talk.